Hello and welcome to TidyX episode 143. TidyX is a screencast where we go through and explain how our code works. My name's Ellis Hughes.
And my name's Patrick Ward. Thanks for checking out TidyX. As always, like and subscribe on the YouTube channel where you can drop us comments, questions, and we might turn one of your comments or questions into a show like we have today, which we'll get into. Also, if you love what we're doing and you feel like it's impacted you in a positive way and you'd like to donate back to the show, we do have a Patreon page and we're always super appreciative of anything you'd like to share. That said, episode 143, 4 and 4, we're going to go through 4 different ways that you can express a for loop and get the same result out. And this is all about the syntax and kind of what makes sense to you given the problem that you're solving for. And this came from a question from a sports scientist who was working at a university, and he has 10, 12, 14 varsity teams. And he's got a bunch of team data, and the players on each of those teams were tested in 2 different variables. And what he wants to do is figure out a really elegant and simple way of calculating the correlation between the 2 different variables within each of his different teams. So that's what we have for the setup of our data. We're going to simulate some fake data here. We're going to create a Tibble. We're just going to create some fake athletes that are going to be lettered, A through whatever 9-letter is, not I, A through I. We have 3 teams. We have 2 different variables that we're in some way, we're going to measure the correlation coefficient between them. And then we're just going to calculate some fake variables. So just random normal distribution for variable 1 and random normal distribution for variable 2 with a little bit of noise added to it on the end. And that gets us some simulated data. And so this is what his data looks like, but it's like several thousand rows because he's got a whole bunch of athletes and a whole bunch of teams. So in order to get this into a simpler way for us to do the correlation coefficient so that we don't have to deal with like lag values within athlete and team, we're just going to pivot this out so that we get it into 2 different columns for variable 1 and variable 2. So first, we're going to take the data for variable 1, we're going to pivot it wider, and we're going to rename, actually, we don't need that rename. I don't know why I did that, because I think I had a space originally when I wrote the simulation, and so we can trash that and rename, and we'll be fine. But we're gonna do variable 1 first, and then we're gonna join it to variable 2 based on athlete and team, and this is what our final data set looks like.
Yeah, we're not focusing too much on this bit of code right now. No. This is just to get us to the setup. I think you could probably also do a pivot wider from here, and it'll get you the same way too.
Oh yeah, I don't know why I did the 2 different.
It's just kind of fun to write complicated code sometimes.
I guess, yeah, I don't know why I did that. That's not I think I had something else. This is what happens when you borrow simulations from other projects that you wrote. And try and make
it made sense at the time. I'm 100% sure.
Yeah. So,
but we're not focusing on that. What we're focusing on
we're going through for loops.
For loops. Yes. So we wanted to go through 4 different ways you could set up your for loop. And how that impacts the code that you write. And no one is necessarily a bad way to do it. It's more what makes sense at the time and what you're trying to achieve and what are the assumptions you can make about the data that you've got going on here. So this first one is probably the one that most of us have seen right when we get started with using for loops. So first we're going to, from wide.dat, get the unique teams that exist. And so this is teams 1, 2, and 3. And we're going to pre-generate a data frame that's going to hold the correlation coefficients that we're going to be storing here. So we're going to take data frame. It's going to take the vector teams, and then the COR column is going to be populated with NAs. So you've got that there. But what we care about is the setup here and how that impacts the rest of our code. So in this situation, what we're saying is for every instance of every value that's in this, from 1 to the length of teams, for every value in there, replace I with 1, then 2, then 3, and then if it goes more than that, use that value. Calculate or filter out to keep the team of interest and drop that into T. And then we're going to calculate the correlation coefficient between var1 and var2 and drop it in the ith row in the second column of core coef. So what this is going to do is for 1 to length teams, which length teams is 3. So this is going to be 1 to 3, right? So I is 1, then 2, then 3. Filter it out, then drop them in the core coef. Great. We got those values. Voila, filled it in real nice like. So one quick danger of this is if you have a data set that came in wide dat, because the issue is this: if you drop this into like a function or something that you're using more broadly rather than the specific situation that we're in right now, length teams could return 0. And so what that's going to return is understanding how this piece of code works is 1 to 0 is going to return you values 1 and 0. So now we've got it iterating over backwards the way that you're not intending for it to go. Oh my gosh, now you're going to be trying to pull out the 0th index from teams, which of course in R doesn't exist. We're not Python.
Only in Python. Yes, only in Python.
So you're going to get these error messages in your code, and it's not necessarily going to be obvious that that's the issue, especially if it's kind of buried in your analysis. And so a better way to do this much more safely is we're going to have the same setup here. We're going to pull out teams and pull out core coef. But what we're going to do is we're going to use this function seqlen. And what seqlen is it allows you to pass a number saying, I want to iterate from 0. It's assuming 0 is the base or the start number, or excuse me, 1 is the start number to n. So n being however long it is. So then we'll call the length on teams. So again, length on teams is 3. We call seqlen on that, and that's going to return us a vector of 1, 2, 3. Now, if we update that to be 0, it's actually going to return 0. So this for loop won't even run and execute in our code because it's iterating over an empty vector. And if there's no vector for it to iterate over, it just doesn't run.
And we could have done that with seek along as well, right?
Yes,
seqlen,
exactly. So
or seek along. Both of those would have worked. The base R version is seek along.
Yeah, so that's actually the next piece. So let's run that just to verify that this is indeed... You're getting ahead of yourself, Patrick.
Sorry, I got excited. I got pumped up.
Just verifying that we got the same results here. Perfect. Now, next we would do seek along. Patrick, do you want to talk a little bit about how seek along is different?
Well, okay, so we're going to give the same setup, just to like level set. We don't have to do this every time. We're just kind of doing it to show that, like, let's start over as if we were starting from scratch. So if you just run seek along teams, go ahead and run that. Oopsies. We get 1, 2, 3. If we had seek along and someone dropped a 0 in there, what happens? We get 1. So the last one, seek len, gave us a nothing, right? A big nothing burger. Now, so seek along, so seek len would have produced nothing, right? Like if we ran if there was 0 teams in wide dat and we ran that for loop, well, we have got nothing back. We would have got an NA back, right?
It just wouldn't have run.
It just would have barked an error, wouldn't it have? Maybe not an error.
If we drop 0 in this guy
here, I think we just get like
will just skip the for loop because it's trying to iterate over an empty vector, and because there's an empty vector, it's just going to skip forward.
That's why I did it. Okay. Yeah.
The difference here is if you seek along is looking at the object that you entered. And it's going to iterate over, like, what is the, like, minimum, what is the length of that object?
Yeah, it starts the counter directly at whatever the start of that. So, yep, there you go. So 1, 2, 3. And so now if we run this, we're going to get the same result. But seek along is always starting at the first index. So no matter what you drop in there, it's going to say, hey, that's the first index. That's where we begin the for loop. Therefore, whenever we get to line 82 and 83, the teams is being filtered by whatever's in that first index spot. And here we go.
So yes, so seek along is
Yep.
take the length from the length of this argument. That is,
Yep.
beautiful English.
Always the start. Yep.
And seek len, desired length of the sequence.
Yep.
So the value is like for seek len is let's actually see what happens. Seek len -4. It won't let you do a seek len of -4. So
But
it
seek
all you
along will
always
give
have to
you.
pass a positive, at least a 0 or
Yep.
greater value.
Yep.
But for seek along, it makes it so you don't actually have to think about it. It's just you just pass in the vector you want to iterate over,
Yep.
and it'll give you the indexes to iterate over it.
Yes.
I
And
think is like the simple way to think about it. I think.
I've never used seek len in a for loop. I've always used seek along, just the way that I've done it. But yeah.
It's a little bit
Okay.
safer and a little bit simpler, I think, to when you're reading the code, because when you're reading this code, right, you have to
Yeah.
go, okay, seek len, okay, but we're going to do this for the entries in
Yes.
the length of teams. In this is more saying for every entry in teams do this, and it's
Yes.
maybe
Yes.
just a slight shift in the way that you wrote it and therefore the way you think about it, but code should also be readable, right? You want to write your code in such a way that when you're looking at it you immediately understand what it's trying to do. um, and I think this can get a little bit confusing. Meanwhile, this is just for
Yeah.
everything that's in teams.
More clear. Yeah.
Mm-hmm.
And then the fourth iteration we're dealing with here is going to be uh, we have the same start, same type of start function, or sorry, start elements where we have teams, we have a correlation coefficient. The difference here is instead of iterating over the index position, so before we're doing index 1, index 2, index 3, we're actually going to iterate over the team names. So this would be like if you had to do this on a vector of names like Molly, Tom, and Jim, and we always want to take the average of them. We're going to do that exact same thing here. We're going to go over these teams, and we're going to identify the correlation coefficient by team name. And so we've changed in line 97 from the I index. We've just changed it to team name. You could have left it as I as an index, but we changed it to team name so that it's just, again, more explicit, so that the code is clear that we're actually looking at a named vector. Okay. Line 102 is going to be the exact same. We're just filtering out the team. This time it's going to equal the team name because we're dealing with the explicit team name. And then here, where we're going to store the results, we pass team name right there in the first kind of area there. What that's going to do is we're trying to make sure we store the correlation coefficient in the row for the team name. And you can see up in line 95, we've added one argument to our data frame, which is to pass the team's names to the actual row index, so that it just makes it clear what it is we're storing. So there we see team. Yep, team 1 is row 1, team 2 is row 2, team 3 is row 3. We run this, and we're going to get the same results: 0.54, 0.99, and 0.556 if we're rounding up. And that gives us the exact same results, and that's just iterating over the actual team names. And now the last one we'll have Ellis walk through is going to be dealing with a list, or iterating over a list. So sometimes, we talked about this last time in last episode, sometimes using lists is really useful because you can store lots of different variables in different list elements and call those later on downstream. Also, lists can tend to be really fast if you're dealing with big data sets and things like that. So go ahead and walk us through how to iterate over the actual list now, Ellis.
Sure thing. So yeah, this is a bonus one. It's a little bit different than the other ones. So the other ones we were passing in vectors, right? It was a vector of numbers. It was a vector of team names and whatnot. All of those were based on this mental construct of a vector. For loops don't only have to go over a vector, though. They are able to go over a list, because basically what you're saying is for every entry in this object that you're passing,
Yeah.
that's what I'm iterating over. And
Mhm.
so that's why we're able to iterate over lists. So what we're going to do here is we've got our teams and our core coef
Yep.
data frame again. Again, we're using the row names, row.names as teams because we want to have this be named, which allows us to enter in the values later. We're going to take wide dat and then we're going to do a group split on team. What this is going to do is it's going to give us a list of 3 where each team is independent in an entry in the list. And what that lets us do is we can now, for team dat, so dat standing for like data or data frame or whatever, for team dat in wide dat list, so every entry in that list, what we're going to do is we're going to calculate the correlation coefficient, pull team dat, which is for the first entry, this data, this tibble, for the second entry, this tibble, and then for the third entry, this tibble. Calculate var1 and var2, drop it into core coef, but of course we want to record it and we want to record it in the right spot. So we're going to pull the unique team dat of team. Of course, we probably could have also done it like this, just pulled out the first entry out of team because we know that all of these values should be the same. But I think it's just when, again, for code readability, even if it's less efficient, this is easier to read to say, I want every unique value of team. And that's how I'm going to drop it into core coef. So we're going to run that. And as we can see, we got the same value as well. So again, these have been overwritten, 5 different times, 4 and a bonus, I guess. So 4 for 4.
4 for 4. Yeah.
But it's just observe the way that our for loops change the contents a little bit. Where when we started iterating over actual values as opposed to an index, we had to change the way that we were creating our data frame that was storing the resulting output. Because in this situation, we actually don't have an index. We have the actual name that we care about. Or in this
Yeah.
situation, we have the raw data that we care about rather than an index. I mean,
And
we totally could do this in such a way that we are doing a seek along on wide dat list,
mhm.
right? So now it's going to pull out the 1 through 3, but that's because it is the 3 entries in the list. And
Yep.
this goes back to I.
Now go to
And
I.
then
Yep.
we construct team dat. So this is like how you can jump between the different ways that you're setting up your for loop. So team dat is wide dat list, I. Update this to be I. All of a sudden we're back to the same way, but now we have a for or a list that we're iterating over, pulling out that raw data, and then dropping it into core coef. So
And the only other thing is on example 4, where we used row names. Is this it? Was example 4? Yeah, row names. We could have not used row names, but in that first piece of the data frame there at line 105, we would have had to do something like where team name equals yes, and then
in $sign.
team equals team name, because now we have to just be explicit that we want to find it. And so that just kind of doesn't look as clean as the other example where we just have to basically give it the team name and you're sort of set to go.
Yeah. So all that to say, like, there's a lot of different ways you can set up your for loops and the contents that you're entering into your for loops to iterate over. But recognizing the impact that it has and the readability it has on your downstream code. Because ultimately the thing that matters is in 6 months' time when you go to look at your for loop, trying to understand what's actually going on here can be a little bit difficult. And also note, we are specifically talking about for loops here. We're not talking about per or other ways to iterate over values. We can get to that in future episodes. Like and subscribe, drop a comment down below for us to know if that's something you'd like us to get into. So with that, I think that can be episode 143. And we're still going to call it 4 for 4 loops. 4 in 4 loops. As always, my name is Ellis Hughes, and you can find me on various social media sites at Ellis_Hughes.
My name is Patrick Ward. You can find me on Twitter at OSPPatrick and at Tidy_explained is where the Tidy screencast lives. The TidyX screencast lives on Twitter. Tidy.explained@gmail.com is where we are on Gmail. As Ellis said, liking and subscribing on the YouTube channel is like the most easiest way to comment, question, and interact with us, and maybe get one of your questions, thoughts, or ideas onto the screencast. Additionally, we love doing this, and if you love hearing us do it and you feel like it's positively impacted you, we do have a Patreon page. It's in the notes on the screen on the YouTube channel. Feel free to donate whatever you would like. We're always appreciative of those who give back to us, because we like giving back to you.
All right. With that, thank you all so much, and keep on exploring your world.